Okay, guys, let's go ahead and go on with problem 1 for exam 2 review. We're going to do parts E through I. Again, parts E through I. Okay. All right. So again, we've got our football fired off at 40 meters per second at an angle of 60 degrees. Now we want to know the total time of travel before the football hits the ground. Okay, just to remind you, again, there's our trajectory here. So total time is what's the time? What time does it take for the football to go from this point up through the entire trajectory and hit the ground? Okay, and remember, we know that the time up is equal to the time down. Okay, alrighty, and we already know the time to reach that point, which is 3.5 seconds. Therefore, the total time, okay, is just twice that, which is just going to be 2 times 3.5 or 7 seconds. Okay, so our total time in the air is 7 seconds. Okay, next question. How far does a football land away? That's its horizontal range. Okay, all right, so we know the velocity initial in the x direction is 20 meters per second because we already calculated that. Okay, its initial position in the x is just 0. Okay, so again, let's go ahead and write our equation for its displacement in the x. So x is equal to its initial position plus its velocity initial in the x times the time plus 1/2 at squared. Okay, but we remembered that its acceleration in the x direction is 0, so that term just drops out. Its initial position was 0, so this is pretty straightforward. Our distance traveled in the x is just going to be the velocity initial in the x times the time. Okay, and that's just going to be 20 meters per second times 7 seconds. Okay, or 140 meters. Okay, so that's our range, 140 meters. So that's the overall distance it moves in the x direction. Okay, all right, velocity at maximum height. Again, that's straightforward. We know the velocity at maximum height in the y is 0, okay, but I think they want the total velocity, so that's going to be both the x and y components. We also know that the velocity in the x at any given time is just the initial velocity in the x, okay, so which is 20 meters per second. Okay, so the answer to this is just going to be 20 meters per second in the x direction. Okay, all right. Okay, acceleration at maximum height. Again, there's no acceleration in the x direction, so the acceleration is just going to be minus gravity, which is just minus 10 meters per second squared. Okay, all right, the last question is asked for the velocity with which the ball hits the ground. Okay, and so in order to find that, we've got to find the y component of velocity and the x component of velocity. Okay, so again, so the y component of velocity v sub y is just velocity initial in the y minus gt squared, minus gt, no squared. All right, and that's just going to be 35 meters per second minus acceleration, which is going to be 10. Okay, times the time, 7 squared. Okay, so and then when we calculate that, we end up with, 35, actually minus 35 meters per second, and that just means that the y velocity is directed downward. Okay, all right, and again, the velocity in the x, okay, is just going to be the initial velocity in the x, which is going to be 20 meters per second. Okay, all right, so now to find the overall velocity, which is indicated right here, which is going to be the vector sum of v sub y and v sub x. Okay, we'll just call it v sub final or v sub f. Okay, is going to be just the square root of v sub x squared plus v sub y squared. Okay, which is the square root of 20 squared plus 35 squared, and this will give us about 40 meters per second. Okay, all right, and again, that's good. That's what the velocity was on launch, so that sounds pretty good. And to find the angle, again, just a little bit of trig here. Okay, let's take the tangent of theta. I know that the tangent of theta must be equal to the opposite side, which is going to be v sub y divided by v sub x. Okay, so that just means that Theta is going to be the inverse tangent v sub y, which is 35 divided by 20, and this will give us an angle of 60 degrees. Okay, and you can see that's exactly same numbers we had on takeoff, except with the direction being different. Okay, all right, so again, we're 40 meters per second at an angle of 60 degrees. Okay.